Okay, so there's this great this guy, some university in Texas, name's Paul. He put together this great set of notes here, and I refer to it often with students because there's just too much to remember. Some teachers are really big on you actually writing down like all the conditions of Rolle's theorem. I'm
Yeah.
not big on that, but that's something you could see. You could see that, okay, you have to write, you'd actually have to say this, the function is continuous on the interval. So in your problem, you'd have to say from -2 to 2. You'd then say it's differentiable on the open interval -2 to 2. You'd have to show that, and we did that for that f of a equals f of b. Then we can do Rolle's theorem. But they sometimes want you to list that. Does that sound like your instructor? Or
Yeah, he does want us to do that.
okay, they don't make you do that on the AP. They just make you do a problem like this. But you should do what they want. They're grading you. All right,
Yeah.
so you have to be able to take a derivative of this, and you're setting it equal to 0. So we talked a little about this yesterday. Any idea how to solve this by factoring or quadratic
Um,
or worse?
I have to multiply the two outside, so -12, right? Something with -12, and like two numbers have to equal the.
But sometimes you get a problem. This is one of them where there's nothing that works. So,
Uh,
and that is the solution here. You do have to use quadratic formula for that. Does that also sound like something your instructor might ask you to do?
he might. We didn't do anything like that in class, but
As
he
a
would.
reminder here, yeah, as a reminder here, quadratic formula is -b plus or minus the square root b squared minus 4ac over 2a.
Okay. So -2 plus or minus. Okay. And I just plug in those numbers and wait. What am I solving for exactly?
You're solving for something that's in this interval.
Okay, for an x value in the interval. Okay.
And that's where it gets really hard is you have to know, because you don't really know what these look like, what these numbers are. You have to put the numbers in, simplify. And I do have the solution. I wouldn't mind having you work this out, but you then want to know whether it actually falls in the interval or not. Sometimes they don't, but this one I believe they both do.
Yeah. 4. I'm getting -0.82.
Okay, so you're just full on putting it in the calculator. You're not doing
Yeah.
the traditional. Okay. If your teacher will allow that, I'm okay with that. The answer is 1/3 plus or minus square root of 13 over 3, if you wanted to do that.
Plus or minus over 3. Oh, because the twos cancel out, right?
Yeah,
Or
yeah. I mean, do you want us to work through this? I'm happy to.
actually, yeah, because I don't think I know how to do that.
2 squared minus 4 times -3 times 4. You do know what it is, just haven't done it in a while. Um, so this becomes inside, the biggest issue is inside here. This ends up being 48, and then that's 4. So it's -2 plus or minus the square root of 52 over -6. Square root of 52 reduces to 2 and 26, 2 and 13. So you can pop a 2 out. -2 plus or minus 2 square root of 13. You divide each by -6. So this is 1/3. The negative on the bottom, it goes with a plus or minus to just make it plus or minus again. So you don't have to actually do anything on that. And then it's a 1/3 square root of 13.
Okay, that makes sense.
All right.
I do remember
Uh,
that.
yeah. So occasionally I give you a problem that isn't differentiable everywhere, and like that you're not allowed to use Rolle's theorem. And I don't know if you're if that's the kind of problem your teacher might give you.
He
But that's
mentioned it, but like he didn't put much emphasis onto it.
yeah. So sometimes you see something, you get so in tune with like, oh my gosh, I guess I should just like do this, and you forget, okay, like maybe I should take a derivative first. 2/3 x to the minus 1/3 power. And the problem is here is that if you were to rewrite this, it's 2/3 1 over x to the 1/3 power, which is 2/3 cube root of x, which has a problem at 0. X cannot be 0. It's not differentiable there.
Oh, okay. So
And so
I
that doesn't satisfy
Rolls theorem.
the thing, right? But
Okay.
if I were to give you the same problem and give you a different interval, which doesn't actually work in this problem, but let's say I could give you an interval that excluded that place, then you would be okay.
Okay.
But this doesn't actually work, so we don't have to worry about that.
Okay.
That's the reason. That's more the reason to know this list is because occasionally you get an exception to the rule.
Yeah.
Okay, so we should do some mean value theorem problems next.
Yeah.
Is that okay?
Yes.
All right. So there's a whole other list of rules for mean value theorem. See if I can pull those up.
Okay.
Right,
Oops.
sounded bad.
It was just my picture frames.
All right, so it's got a lot of the same stuff. It has to be continuous and differentiable.
Yeah.
That's the first thing. So those two are the same in both. You might be worried about this when x is 0, but that's not in the interval. You do always check the two endpoints, and this one you do something slightly different. So could you calculate these, and they do need to be fractions this time.
Yeah. Negative 35 over 18.
Okay, and one f of one.
Um, negative 2. Oh, wait. Hold on. 0.
Okay, so you have to do this average rate of change f of b minus f of a, b minus a. So in your problem, it's f of 6 minus f of 1 over 6 minus 1. So you're using this result, and then 6 minus 1. Can you tell me what that becomes?
Yes. Negative 7 over 18.
Yeah, -7 over 18. So why do we need that number? Because when you take the derivative of this thing, there's a
Okay.
place where the derivative will equal -7 over 18. So you have to take a derivative of this. Oops.
Okay. Quotient rule, right?
Yep.
Mm. So negative 6x squared minus or plus 3x squared plus 3 over 9x
I got
squared.
-3. Just double check that.
Oh, yeah. And then
So it looks really bad. Like it looks like, oh man, how am I going to solve this? But you can do
no.
it. You cross multiply here. -54 x squared minus 54 equals -63 x squared. You end up moving the 63 x squared over and adding 54 to both sides. And you get 9x squared equals 54. Divide by 9. You get x squared equals 6. So x equals plus or minus the square root of 6, but you have to pick the one that's in the interval from 1 to 6. And therefore
So 6, right?
it's only the positive square root of 6.
Positive. Okay.
Okay, let me see if any of these work out nicely. Number 10 does that I found on this one. It's not too bad. But yeah, why don't you try number 10 on your own here? This is a mean value theorem problem. It's a little bit easier and it's a nice answer. Um,
Uh,
I'm gonna just step away for 30 seconds to grab something to drink, but I'll be right back and we can talk about how to do this problem if you have any questions. But it is a mean value theorem problem.
okay.
How are you doing on this one?
Pretty good. I just did the equation and I'm on like finding the derivative and setting it equal to
Okay.
um my like using the equation, I'm setting the derivative equal to 3 halves.
Okay, that sounds right.
And then for my derivative, I got negative x plus 4,
Okay, so you got to set that equal to
3
3
halves.
halves.
I got x equals 5 halves.
That is correct.
Okay.
So I think you're noticing um, the procedure is the same for Rolle's theorem, the mean value theorem. Like sometimes they're they appear different. You the only difference graphically that is the easiest way to do it. Rolle's theorem requires you to have the same heights, the same, f of A and f of B, whereas mean value theorem, they are not at the same height,
Yeah.
but you get the same thing. You get the secant line is the same as the tangent line, or the tangent line. There's always a C in the interval. So this is Rolle's, and this is the mean value theorem.
Okay.
Right. Do you feel like you understand the difference between them, or more importantly, I guess, how to actually do them? Or do you want me to
I
answer
actually
more
think
problems?
I understand them.
Okay. All right. So next up on your list um, could be, dy, delta y differentials, errors, tangent lines, Riemann sums. Anything
Maybe we'll
stand
go
out
through
to you?
some Riemann sums
Okay.
again. Yeah.
Sounds good. Now, are you doing all of them? Left, right, trap, mid? What are you doing
Yes. All of them.
for all of them? All right. How lovely. Okay. Um, and you're using a calculator for sure?
Yeah.
Okay. So a problem might look like this. You might say the integral from 0 to 3 e to the minus x dx, and we want to do n equals 2.
Okay.
Okay. So could you calculate your delta x for me, please?
Yeah. 3 halves, right?
3 halves or 1.5, depends on how you want to look at it. Let's say, and I mentioned doing this where you actually write out the left bound, and then you go up by the delta x.
Yeah.
All right, so now the reason we do all this is because the left, the right, the mid, the trap, they're all based on this. So let's
Okay.
do the left. Left sum is delta x times f of 0 plus f of 1.5.
Okay. So left equals 1.5. And we don't do the last one because it's left, right? For the left one, we don't do the last, and for the right one,
Well,
we don't do the first.
that's the outcome, but it's because you have two rectangles and you have two rectangles. You have f of 0 and f of 1.5. Those are each the rectangle heights.
Okay. Okay. I got 1.83.
Okay. All right. And you multiplied by 1.5.
Yes.
Okay. Very good. So I think the confusion you had last time was like, where do I put the 0 and the 1.5? It's back into the function there.
Yeah.
Okay. So the right, and we're just gonna do the right, and then I'm gonna switch functions, and we'll do a trapezoid and midpoint. So this is
Okay.
f of 1.5 plus f of 3. So it's 1.5 e to the minus 1.5 plus e of minus 3.
Okay. I got 0.41.
Okay. Any questions on that before we do something else?
What exactly are the numbers that I'm getting? Like, what do they mean?
They're so the e to the minus x looks like this. And so they're the rectangle heights. That's the left sum, the
Okay.
right sum.
So it's the height of the rectangles?
Well, these are areas of the rectangle, so they're meant to approximate the area under the curve,
Okay.
and they're not very good. But we talked a little bit about the city of like overestimate, underestimate.
Yeah.
So the ones on the left are over because of the shape of the curve. It's not because they're left estimates, because of the shape of the curve.
Okay.
The ones on the right are an underestimate. The rectangles are under the curve.
Okay.
So like you asked, like, what are you doing? These are techniques to determine the area under the curve without knowing how to do it directly.
And so, like, the delta x is like the bottom of the triangle, right?
Okay,
And then,
rectangle. Yeah. So yeah, so that's delta x. And then this point right here is f of 0. And then this height right there is f of 1.5. This was f of 3. That was f of 1.5. So it's the height.
okay.
You're multiplying the base times that. Now I understand what you're asking. I apologize.
Yeah.
You're finding the area of the rectangle.
Okay.
And they all have the same width. That's why the delta x is pulled out.
Yeah.
Okay, let's do another one here. Let's do integral from 0 to 2 pi. And we'll go x tangent x dx. And this time I want n equals 4 rectangles.
Okay.
Actually, no,
Um,
that's too much. I'm sorry, that's too much. Let's just do 2 again.
okay. So 2 pi minus 0 over 2. Okay.
Okay, so now we're gonna do the midpoint. So you actually need the midpoints.
Um,
You're finding the average or the middle of those two.
isn't it? Okay. Yeah. Pi over 2 and 3 pi over 2.
Yeah, if you see that I've done something wrong, please ask because I do make mistakes.
That looks good to me, so.
All right. So the midpoint formula is delta x times f of pi over 2 plus f of 3 pi over 2. So it's pi times um, pi over 2 tangent pi over 2 plus 3 pi over 2 tangent 3 pi over 2.
Cool.
And I've actually violated some things here. So hopefully no one on YouTube comments that this is ridiculous. But the whole point is just that you don't do this in your calculator, it won't work. Um, well, it will, but it won't. So, uh, but you understand I don't know the recipe, the steps here.
Yeah.
Great. All right. So trapezoid rule. Some differences with the trapezoid rule. It's delta x over 2, but you this time use all of the points. So use the
Okay.
leftmost endpoint, and then any of the inner ones you double, but then you get back to singularly using the other endpoint.
So like, what if we had four? Like, let's say we had four increments instead of two.
Okay.
All like the inside two would be doubled, right? And then the
Right.
outside.
The edge ones are the only ones that get the edge ones are always singular.
Okay. And does that work if I plug that one in? That's not gonna work if I plug.
No, none of these will work. I mean, they will, but they won't. I mean, it just apologize. I
Yeah.
we're not. I'm just trying to throw out some problems. They're a little different so that um,
Yeah.
you kind of get a feel for what you might see. So, I mean, that without like, I mean, I can give you more to do, but do you
I feel like those ones are pretty easy actually.
if you know the formulas, you know how to split them apart. That's you're
Yeah.
comfortable with your calculator. I made them kind of easy with n equals 2. It can get harder with incrementing and stuff like that.
Uh-huh.
So, um, we can move on to something else. We got about 15 minutes left.
Yeah.
So,
Maybe like the antiderivative stuff, I guess.
okay.
Like indefinite integrals.
So here's a basic problem for you to try. Let me know if you're not using this notation. I can't remember. I have to look at our notes. Is notation okay?
Yeah, that's good.
All right.
And I'm finding the antiderivative, correct?
That's right.
Okay. Okay, I got that it equals x to the power fifth of to the power 5 over 5 minus x to the power of 4 over 4 plus x to the power of 3 over 3.
Plus C.
Oh,
Very
plus c.
important. Plus, very, very important.
Okay.
Okay, so let me give you another one here to try. So they can use different variables. Doesn't have to just be X. If you don't like X, change it. Or don't like the letter, just change it. But
Okay.
you might see something like this.
Okay, for the first, like, the 7u to the power of 3 halves, I got 14 over or 15 fifths times u to the power of 5 halves.
like that.
I got 14 over 5.
Okay.
Does that seem right?
So to answer your question, we're going to take a derivative of this. The derivative is 5 over 2 times 14 over 5, u to the 3 halves. So does
Uh,
this part reduce to the 7?
I don't think so.
You should have more confidence in yourself. It does.
Oh. Oh.
I'm asking because that's how you would check.
It just looked like too many questions, too many like numbers. Okay.
Well, you can always check these, but you then generally don't have enough time to check them.
Yeah.
So you have to trust your ability to manipulate the numbers. But go ahead and keep going. See if you can come up with
Uh,
the next one,
four
please.
thirds u to the power of 3 halves
Okay. Anything else?
plus e.
Okay. That's pretty good. I always like a problem where you have to yourself rewrite the roots and exponent notation.
Okay.
So there's a rewrite step here,
Yeah. Minus
and
3.
that's what I'm mostly interested in.
Okay, I did 5y to the power of 1 half
Okay. Anything else?
minus 3y to the power of negative 1 half.
Okay. Very good. And that's key here. If you can't do that, you'll be in trouble here. But yeah, go ahead and integrate that, please, or find the antidote.
Okay. Okay, I did 10 thirds y to the power of 3 halves minus 6y to the power of 1 half plus c.
Good.
I remember doing like some of these, but like with u substitution. Like,
But yeah, I mean, we can get to that.
yeah.
Do you want to jump right to that?
Yeah, what's the difference between that and this?
Well, these are all easier than that, and the um, your substitutions get really difficult. But I'll grab some problems here
Okay.
for that. Um, so ignore the numbers here. I'm gonna scratch them out once I zoom in. Let's ignore
Okay.
these numbers. This is a U substitution problem. Please check with me before you do the U substitution. That way I can tell
I
you,
have to rewrite it first, though, right?
you do not. You did not
Oh,
on this one.
so then actually I don't know what to do.
So the U substitution is x cubed plus 5. And you have to first take a derivative of that.
Okay. So, how do you know that that's what we're substituting?
Well, it's like a guess and check. Um, you you eventually learn that it's things that are in parentheses, under roots, in denominators, exponents, stuff like that.
Okay.
That's the whole challenge, is to figure out what the U is.
Okay. So du equals 3x squared.
Dx, and then you solve for dx.
So dx equals du divided by 3x squared.
Okay. Now there's two things you're going to substitute in for. You're gonna figure out, where to put u, which is this. that's going to become u. And then you also substitute in for
dx.
dx, which becomes, all of that.
So du over 3x squared. Oh, wait, my du is wrong. Wait. Oh, never mind, never mind.
And then hopefully you get rid of your x's.
Oh, okay.
And that's the whole point of the u substitution is it's supposed to get something like nice that you can integrate. Excuse me. If you could integrate that for us, please, or antiderivative. Let me
I
know
plug
what you
in. Do I plug in x cubed again, or
Nope,
no?
nope. You got to find the antiderivative first.
Okay. U1. 2/3 u to the power of 3/2. Is that right?
Okay. Plus c.
Oh yeah,
And then you have to
plus c.
back substitute. You have to put that u back in. If you
So
don't,
2/3.
you'll miss some points on that.
Okay. X cubed plus 5, 3/2 plus c. Okay.
So final answer is 2/3 x cubed plus 5 to the 3/2 power plus c.
Yes.
All right. So here is, let me give you a little bit more difficult one. Um,
Okay. I'm substituting for ln of x, right?
yes, that is the right one.
Okay.
And the
So
other thing is that your derivative, your du has to be in there. Like you should see 1 over x, and you do. You see that there's an x on the bottom.
okay. So dx equals du over x. Oh wait, times x? Oh yeah. Mm. So the x's cancel out. Oh yep, okay. And then negative cosine of u
Okay.
for the antiderivative
Anything else?
plus c.
Yeah. So I won't be there on the quiz. You're gonna have to remember that. It's really
Oh
important.
no.
So, and don't forget to back substitute in.
ln of x plus c. Okay. So negative cosine ln of x plus c.
Yes. I don't know how many antiderivative rules you learned, but here's another one to look at. It's another use
Mm,
substitution.
okay. Since there's no parentheses or anything for this one, how do I know which one? Oh, okay.
So sometimes it's the denominator.
Okay. So u equals e to the x plus 1. So dx equals du over ex, right? Yeah. Okay. Equals du over ex.
This is what I was wondering if you guys had covered all the antiderivative rules.
We did, but I honestly don't really know what like the e to the x really
So
is.
the EDX cancels. It's just natural log absolute value of u. That's why
Okay.
I chose this one. It's kind of an important one to remember that it's absolute value. It's not just u. And then you have to back substitute.
over u du. Okay. So wait, I'm actually confused. How does the 1 over u turn into natural log of u?
That requires a Taylor series, which you'll learn in calculus 2, which we're not going to do. It's going to take
Okay.
about another hour to explain that. So you're gonna accept that this is true. Sometimes people say you just go with it.
Yeah.
Like, why is the North Pole north? I don't know. I don't make the rules. This is what we got. Okay, let me really quickly show you one more. I'll work this one out fully and
Okay.
we'll close out our lesson here. So the u here is cosine t. The u is minus sine t dt. So dt is minus du over sine t. Becomes integral e to the u minus du over sine t. That negative you can bring out. Negative integral e to the u du is cancel. Antiderivative e to the u is itself. It's the only one that is itself.
Okay.
Plus c. And then you put that u back in. Like I mentioned a few times, if you took the derivative of this, you should get back to the original.
Okay.
If you have infinite amount of time, you could do that, but I'm sure you don't. All right,
Yeah.
we're going to stop there for today. Next